Okay, Unit 1, Day 3. This is the binomial theorem. I need you guys to take really, really good notes on this. This is the hardest concept you're going to learn this unit, okay? So we're going to expand using the distributive property first. So x plus 3 to the third power. That means we have x plus 3 3 times, okay? We're going to multiply the second 2 using the distribution method. So we're going to multiply the x to the x plus 3 and the 3 to the x plus 3. And we end up with x squared plus 3x plus 3x plus 9. Combine those three x's and we get x squared plus 6x plus 9. Then we're going to use the distribution method one more time. So we're going to multiply the x by that trinomial and the 3 by that trinomial. And you end up with x cubed plus 6x squared plus 9x plus 3x squared plus 18x plus 27. Then you combine like terms. So we're just going to combine the 6x squared plus the 3x squared and the 9x plus the 18x. We end up with x cubed plus 9x squared plus 27x plus 27. And you're done. Okay? Let's look at B. We're going to do the same exact thing. So x plus 2 cubed means we have x plus 2 3 times. So we're going to multiply that out. I'm skipping a couple steps, but you get x squared plus 2x plus 2x plus 4 when you multiply those second two binomials. Combine those two x's, you get x plus 2 times x squared plus 4x plus 4. Now we're going to use the distribution property one more time. So we have x times that trinomial and 2 times that trinomial. You end up with x cubed plus 4x squared plus 4x plus 2x squared plus 8x plus 8. Combine like terms, and you end up with x cubed plus 6x squared plus 12x plus 8. I skipped some steps in that, so if I lost you, pause it and try and figure out where you got lost, okay? This is a lot of steps though, right? We have to use that distribution property twice. You could even do it with the box method. You'd be drawn two separate boxes though. So it's kind of a lot of steps. That's when the binomial theorem comes into play. So let's go through some vocabulary. The operation of multiplying a binomial to a specific power, then writing the polynomial in standard form, is to expand that binomial. And then for every positive integer n, a plus b to the nth power, blah, 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 blah. That is the binomial theorem. Okay, we'll get more into that later in this video. Okay, a rectangular array of numbers in which the first and last number is 1, and each of the other numbers is the row is the sum of the two numbers directly above it. That's Pascal's triangle, and that's the triangle that's directly on the bottom of this page. Okay, let's go through this triangle and figure out how we're getting these numbers. So let's start with the very top. The very top, this is the 0 row. I might label that as 0, okay? This is the 0 row. This is not technically a row. It's just 1. You always start with 1. We're going to go to the next one. So we have 1 on the top. Now we have 1 and 1 on the side. We didn't have any numbers above that we can add, so we just have 1 and 1. Go to the next row. You always have 1 on the outside. And then 1 plus 1 is 2, so that's how we got the 2, and then 1 on the outside again. Okay, now we have 1 on the outside again. 1 plus 2 is 3, 2 plus 1 is 3, and then 1 on the outside. Then we have 1 on the outside, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1 on the outside again. So you always add the numbers directly above to get that number below. The next row, 1, then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then 1. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and then 1. Hopefully you're getting the gist of it. That's the next row. This is the next row. This continues to go on forever. You could go on for as long as you wanted to, okay? So now let's explore the connection between the pattern of Pascal's triangle and the expansion of binomials. So let's start with the 0 row. Remember, 0 is the very top. So a plus b to the 0 power, anything to the 0 power. That could be like 5,700,000 something, 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 whatever, to the 0 power, that would just be 1, which is what that first row is, 1. Okay? A plus b to the first power is 1a plus 1b, which is just a plus b, but those coefficients are the first row, 1 and 1. Okay? A plus b squared, you can pause this and multiply it out if you want, you don't have to, is 1a squared plus 2ab plus 1b squared, which is the second row's coefficients, 1, 2, 1. Third row, again, if you want to multiply this out, go for it. I'm not going to make you though. So it's 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed, which is the third row. Okay? And then a plus b to the fourth, you probably guessed it, it's the fourth row. 1, 4, 6, 4, 1 with the a's and b's in there. Okay? So this is an example, and it's in your notes. I am just going to show you it. You can look at this for a second, see if you can figure out anything, any patterns. But I want to go more in depth with this with our next example. Okay, let's go to this example right here. X plus 5 to the 4th power. Okay, you need to take really, really good notes on this. If you take good notes on this, you will understand it and it will come easy to you. If you don't take good notes and you don't pay attention, this is going to be a hard concept. Okay, so this is to the 4th power. So we are going to draw 5 boxes. It's always one more box than the power. And I'm just drawing boxes because I have a thing with boxes. I like to keep my stuff organized. Okay, so I'm going to draw these 5 boxes. Always one more than whatever the power is. Okay? We're going to use x as our first term and 5 as our second term. Okay, because x came first, 5 came second. And then we're going to put these in the boxes. So we have x and 5, and I put them in parentheses in each box. Okay, and now we're going to deal with our exponents. So this was raised to the 4th power, so we're going to start with the 4th power on our x. So it's x raised to the 4th power. And then we're going to count down from 4, but we're going to stick with our x. So it's 3, 2, 1, then 0. Now we have to deal with our 5, because those also have to be raised to exponents. We ended at 0, so we're going to start back at 0. So it's 0, 1, oh, and then we count up. 1, 2, 3, 4. Okay? And then this binomial is raised to the 4th power, and we haven't dealt with Pascal's triangle, so we need to do something with that triangle. We need to use the 4th row, which is the one with 4 as the second number. And we're going to put these numbers in front of the terms that we have in the boxes. So we're going to put the 1 on the first box. 4, 6, 4, 1. Okay. Pretty straightforward so far. Now, what is anything raised to the 0 power? We just talked about this. It is 1. So we can cancel anything raised to the 0 power, because if you multiply something by 1, it just stays the same, correct? So we have, I'll go back real quick. We have 5 to the 0 power, and we have x to the 0 power in the first and last boxes. So we're just going to put an x through those and cancel those out. Those are gone. Okay? Now the last step is to simplify each box. So that first box, we just have 1, and then x to the 4th, it's just x to the 4th. The second box, we have 4, and then we have x cubed, and then 5 to the 1st is just 5. Okay, and these are all being multiplied together. The third box, we have 6, x squared, and then 5 squared is 25. The fourth box, 4, then x to the 1st is just x. 5 cubed is 125. You can pull out your calculator if you need to, but it is 125. Then in our last box, we have 1 times 625, because 5 to the 4th is 625. Okay? And then we just need to continue to simplify these. 1 times x to the 4th is just x to the 4th. 4 times x cubed times 5, 4 times 5 is 20, so that's 20x cubed. And then 6 times x squared times 5 is 150x squared. 4 times x times 125 is 500x. Then 1 times 625 is 625. Okay? And then the binomial is a sum, so we're going to add all the terms together in descending order. So just in the order that we already have them. So it becomes x to the fourth plus 20x cubed plus 150x squared plus 500x plus 625. And you are done. That's your answer. Okay? Please come to class tomorrow with any questions. If you need to, go back and rewatch at least just that last example so that when we go over this in class, you're not completely lost, okay? I hope I went through it slow enough that you can get it, though. So remember to take the quiz, and I'll see you guys in class.